All right, good morning. This is for trigonometry or pre-calculus. We are going to be talking about trigonometric equations here. So this is trig equations. So I have a little example here. So this is pretty standard. You have 2 sine squared x. Okay, plus 3 cosine x. Okay, minus 3 equals 0. Okay, first problem with this is that when you're going to solve a trigonometric equation, you generally only want sines, or you only want cosines, or you only want tangents. You only want one trigonometric function in your equation. So the first thing we're going to do is say, hey, sine squared x plus cosine squared x equals 1. Therefore, sine squared x is equal to 1 minus cosine squared x. Let's push this to the other side, and that's how we're going to do that. So we're going to have our 2. Now, sine squared was 1 minus cosine squared x. Okay, and then I'm not going to change anything else. So plus 3 cosine x minus 3 is equal to 0. Distribute the 2. So we have 2 minus 2 cosine squared plus 3 cosine x minus 3 equals 0. Now I'm just going to rearrange this a little bit. Okay, we're going to have a minus 2 cosine squared. Okay, just put it in descending order, plus 3 cosine x. And then we have a plus 2 minus a 3 here. So we have a minus 1 equals 0. I don't know about you. I don't like to do quadratics when the first number is not positive. So the first thing I'm going to do is multiply everybody by -1. We're just going to swap the sign here and say cosine squared x minus 3x, cosine x rather, plus 1 equals 0. And all I did was multiply everybody in the equation by -1, both sides. Okay, times -1. And now we have to factor by grouping here. Okay, 2 times 1 is 2. Can you think of two things that multiply out to 2 but add up to 3? Sure, 2 and 1. So we have 2 cosine squared x minus 2 cosine x minus 1 cosine x plus 1 equals 0. Minus 2 minus 1 is minus 3. So let's factor out a 2 cosine x here. Okay, what do we have left? We have cosine x minus 1. And then we have minus 1. And what do we have left over here? We have cosine x. We took out a minus 1, so that changes that plus 1 to a minus 1 equals 0. Now, we're going to take that cosine x minus 1, factor that out. So we have cosine x minus 1, and then what do we have left? We have 2 cosine x minus 1 equals 0. Now we have like an a times b equals 0. So either a equals 0 or b equals 0. Okay. So what we're going to do next here is we're going to say, okay, we've got cosine x minus 1 equals 0, which implies that cosine x equals 1. Where does cosine x equals 1? Okay, so if you're in a standard trig class, you probably had to memorize like the easy angles, and this is one of those easy angles. So that's going to be 0, pi over 2 pi, and then so forth. Okay, 3 pi is going to be -1, so 0, 2 pi, 4 pi, 6 pi, 8 pi, etc. The way we're going to write that is we're going to say 0 plus 2n pi, where n is an element of the integers. Okay, so integers being dot dot dot, -3, -2, -1, 0, 1, 2, 3, dot dot dot. Okay. Now on the other side of this, we have 2 cosine x minus 1. 2 cosine x minus 1 equals 0. So we have to solve that. Say, okay, well, this is 2 cosine x equals 1. Cosine x equals 1/2. Where does that happen? Okay, well, First off, it's positive. So cosine is positive in the first and fourth quadrant. So where is cosine equal to a half in the first and fourth quadrant? Cosine looks something like this, right? So it's going to be about here. So that's going to be pi over 3. So x is equal to pi over 3 or 5 pi over 3. Again, this is one of those angles that you're supposed to memorize. If you went through and type this into your calculator and say, hey, I wonder what. Uh, let's make sure we are in a mode that works out here. Let's work with the degrees for a moment here. So if I say inverse cosine, okay, of 0.5, it's going to tell me 60 degrees. That's pi over 3. Okay, so in radians, it's pi over 3. In degrees, it's 60 degrees. Okay, but you have to know at this point to realize, like, oh yeah, cosine could also be positive in quadrant 4, so we have to get that answer as well. Okay. So here we're going to say, okay, well, it's going to be pi over 3 plus every rotation after that. So we have pi over 3 here, but every time we go around a circle, we're going to hit that answer again. So it's pi over 3 plus 2n pi. Okay. It's also 5 pi over 3 plus 2n pi. Okay. So right now our answers are, our answers for just one time around a circle is 0, pi over 3, and then 5 pi over 3. If we want to go multiple times around a circle, then we're going to have 0 plus 2n pi, pi over 3, plus 2n pi. You could say this is 6n pi over 3. Really, what we're doing is just making sure that we can add these together. Okay, we're just adding 2 pi to it. Okay, because 6 over 3 is just going to be 2. And then we have 5 pi over 3, and again, plus 2n, plus 2 pi. Okay, so we're going to have 6n pi over 3. And again, n is going to be 0, 1, 2, 3, dot, 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 however many times you're going around a circle. Okay, so thank you for tuning in. I hope this helps you get started with some trigonometric equations. Please practice, and good luck.